One of the most commonly asked questions in data science interviews is related to decision tree and random forest. One key feature about decision tree is that they are non-linear in nature. So what exactly is a decision tree? How does it work? And how is decision tree related to random forest? So let's say you have few features or few independent variables. So you will definitely have a range of the values, and when you have a range of such values, they will come essentially from a set of observations. Those observations can be bucketed into different regions or different boxes, and every region or every box can be thought of similar to how you do clustering. They can have their own mean, and using that mean, you can do a regression for a new observation which belongs to that region, that bucket, or that box. And if you have a classification decision tree, you simply can choose the most frequent occurring class in that bucket wherever your observation is. So you have a training set of observations based on that which you build a decision tree, and then you bring a test observation and then use the features to identify which region this test observation belongs to, and then based on that what is the most frequent class of this region. So this is how you build one decision tree. And let's say you make multiple decision trees, and if you combine all of them together, that will give you a bagging of decision trees. Now when I'm saying bagging of decision trees, what I mean is that this decision tree is coming from an approach known as bootstrap data. So when you have a set of observations, you do bootstrapping, and based on the bootstrap samples you build a lot of decision trees and then combine them. And when you combine them, it's an example of ensemble learning. So what you do is you try to identify, when you are mixing all these decision trees, what will be the final output. One way of is taking the average of all the observations if it's a regression problem. So this is for bagging. And a special case of bagging is random forest. And in this, what happens is that rather than using the full set of features to expand your decision trees, what we do is we use a random subset of features to build on our decision trees. The only difference between bagging and random forest is less number of features used to build a decision tree than the full set of features which we have. And in that way, bagging is a special case of random forest when you use all the features for building your decision tree. So you can think of it in both ways, that a variant of bagging is random forest, or a special case of random forest is bagging. So the fundamental building block of bagging or random forest is one decision tree. By using bootstrap samples, you make a bagging decision tree. And when you use a smaller set of features to expand decision trees in bagging, then we call it as a random forest.